we've got a does not replace the counter, and we're talking about evens and odds. So even and odd, even, odd, even, odd. So to begin with, evens, 1, 2, 3, 4 out of the 9 are even and 5 are odd. Because it's not replaced, the numbers are going to go down. So 1 less than 4 is 3, 1 less than 9 is 8. 1 less than 5 is 4, 1 less than 9 is 8, and each pair must add up to a whole. So this will be 8 eighths, so 3 needs another 5, 4 needs another 4. And we want each is even, so even and even, so 4 ninths multiplied by 3 eighths. Equals 1/6. Now when we add them, we want an odd number. Now even plus even gives me an even number. Even plus odd makes an odd number, so I've got 4 ninths and 5 eighths. An odd plus an even also makes an odd number, so I've got 5 ninths multiplied by 4 eighths. If I add two odd numbers, that makes an even number. So that's all my possibilities. 4 ninths multiplied by 5 eighths plus 5 ninths multiplied by 4 eighths equals 5 ninths. P is directly proportional to K times Q cubed. Put in the numbers, so P is 270, Q is 7.5. Opposite of multiply is divide. 270 divided by 7.5 cubed is 0.64. But the question wants a formula, so I need to write it as P equals 0.64 multiplied by Q cubed. Then I'm going to use this formula when big P equals little q. So I'm going to replace the big Q with a little q. Big P with a little q, sorry. Opposite of multiply by 0.64 is to divide by 0.64. And I want to get all the q's together, so I'm actually going to divide by a q. Q cubed divided by another q is q squared. So I've got 1 over 0.64 equals q squared. And then the opposite of squaring is square rooting. So 1 over 0.64, square root the answer is 1.25. Differentiation, so we multiply by the old power, so multiply by 3, 1 less than 3 is 2. Multiply by the old power, 4 times 2 is 8, 1 less than 2 is 1, which I don't bother writing, plus just 4. Now P is where the gradient is 0. Differentiation gives me the gradient. So I've got to solve when this quadratic equals 0. So A equals 3, B equals -8, and C equals 4. So X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Equals 2. We change the positive to a negative, we get 2/3. Here the gradient's 0 as well, so this one is the 2/3 and this one is the 2. So x is 2. To get the y, I need to put it back in this original equation. So I need to do 2 cubed minus 4 lots of 2 squared plus 4 lots of 2 plus 3, which equals 3. Where does it have negative gradient? Well, it's between these 2 points. So x is between 2/3 and 2. A dashed is everything outside of A. So there is A, everything that's outside it, all that red region. So it's the 5, the 6, the 1, the 7 and the 4. Put them in numerical order. Don't have to, but it's those 5 numbers. A intersect B dashed. Well, A intersect B is this overlap, and I want dash, so I want everything outside of there, which are the numbers 2, 3, 10, 5, 6, 1, 7 and 4. But this means I want the number of them. How many are there? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 numbers, so the answer is 8. A intersect B is that middle bit. A union B dashed. Well, A union B is both of them, and I want the stuff on the outside. So it's anything that's purple. So it's the 8, the 9, and then the 1, the 7 and the 4. And again, tend to write it in numerical order. Right, A intersects C is the empty set, so C doesn't contain any of the numbers in A. B union C is 5, 6, 7, 8, 9. Well, B already contains 5, 6, 8 and 9, but C can't contain 8 and 9 because it doesn't overlap. So it's not the 8 and 9. Number of elements in C is 3, so it must be those 3 numbers, 5, 6 and 7. So g of x is 2x over x minus 1. We're doing g of f, so wherever there's an x in our g, we're replacing it with the f expression, which is 2x squared plus 1, 2x squared plus 1. If I expand the top, actually let's not expand the top, let's leave that as it is. 2x squared plus 1 minus 1 gives me just 2x squared. 2's match, so I've got 2x squared plus 1 over x squared. Inverse function is where we take the function, instead of x we put a y, so we've got 2y over y minus 1 equals x, and we want to end up with y equals. So the opposite of divide is multiply. Then we expand the brackets. Then we want to get all the y's onto the left, so we need to subtract xy. And then I want the y on the outside of the bracket. And finally, I can divide by the bracket. So y equals negative x over 2 minus x.